Alright, we continue. What volume of oxygen measured at standard temperature and pressure will be liberated on electrolysis of 9650 coulombs of electricity? So anytime you hear volume, now, and they didn't just stop at volume, they said volume of oxygen. Now, and that oxygen there, the charge there, it is always 4 once it is mentioned in a question like this. I'm going to expatiate in my subsequent video how that came about, but for now, the first thing that you're going to do is, they said what volume of this, right? This one that we have here, it stands for the quantity, right? And the quantity, we said it is 9650 in coulombs, right? And our Faraday's is also 96500 also in coulombs. Then we have our charge, which I have already explained. It is 4. That is the charge for this particular oxygen. I'm going to elaborate more on that, but anytime you say this in this particular type of calculation, the charge is always 4. But I will show you, or I will explain to you how the 4, how we obtain, or how you can obtain the 4. Now, what are we looking for here? They said we should find the volume. That means volume is not given. Now, from our previous solutions, I don't know, there is not anything like volume. We didn't solve something like volume. So because of this, you see, there is a problem. But however, I believe you can still recall, right? Now, we also have a relationship that shows that the number of moles is equal to volume in dm cube all over 22.4 dm cube. I believe you can still remember this, right? So if you can still remember this one. Now, of recent, we solved a problem where we said quantity of charge is equal to number of mole charge and talk of the Faraday's constant. Now, if we substitute this here into this equation, our charge will now be equal to, we have volume, right, in dm cube all over 22.4 dm cube, right, times this times this. So this is what we have here. Now we'll just substitute it into, but before we substitute it, remember we are looking for volume, so we have to make this the subject of the formula. So make volume V the subject. Now here we have will be V in dm cube times this all over 22.4 dm cube. Now this will be all over 1. We cross multiply this, so my dm cube will be times q times this, which will be equal to 2.4 dm cube. Now making this here by the coefficient of this, so that this will cancel this and this will cancel this all over. Now we have q of this, right? Now at this, sorry, there should be q here, right? There should be q here. Now at this point here, our V, which is the volume, will be 22.4 times what is our charge now. Check, see our charge here. So it will now, the charge will now be 9650 all over. Sorry, that's our quantity. Sorry, this is our quantity, right? The quantity of electricity. So now the next thing that we are going to look at is what is our charge. Our charge, we said it is 4 times our Faraday's constant 96500. Now if you multiply this one properly, you're going to obtain 0.56, which is in dm cube, because our volume, we are solving it in dm cube. Now let's continue with the second question. It says calculate the quantity of electricity required to discharge an electrode containing 4.0 moles of this particular. Is just an unknown element, but they give us the charge of that particular element. So let's bring out the data. Now the number of moles here given, right? It is equal to what? 4. Then we have the charge given. What is the charge given? The charge that is given here, it is 3. Now, what again do we need? We need the Faradays. And our Faradays is given as 96500 in coulombs. Now, if you check this value very well, you will now notice they said we should calculate the quantity of electricity required to discharge an electrode containing this, right? Now, in this case, we also have a relationship already. We'll now say using, you know that our Q can be equal to N charge and Faraday. So this is easily, we just multiply it straightforward. So our charge now will be equal to, what is the number of moles? 4 times what is our charge? 3 times what is our Faradays? 96500. Now at this point here, when you multiply it properly, what you're going to obtain is this value in coulomb, because we are looking for charge. Now that is it. Now this is another question. It says how many moles of copper will be deposited by passing 3 farad of electricity through a solution of copper 2 tetraoxosulfate 6. Now, as I told you earlier, anytime you hear them saying a compound like this, we only consider the element, right, as a substance. We only consider the element here. This is just the copper 2. And when we talk about this one, what we are just trying to say is this copper, that's just what we are having. So by implication, our charge, because this stands for the charge, right, and our charge will be 2. Now, how many farad do we have? Farad. So we can say that our farad is equal to 3, because they said 3 farad. And they said, what did they say we should, how many moles of copper? So that means we are looking for the number of what? Number of moles is not given to us. So in this, there is also another relationship which says that number of moles is equal to the farad all over, what do we have here? That is our charge. Now in this case, you substitute it back. Our N now will be equal to, what is our farad? It is 3 all over, what do we have as our charge is 2. Now here, if you divide it properly, you're going to have 1.5, which is going to be in moles. That is our final answer.